Module 7, Investigation 4, using sine and cosine function to track circular motion. Note, consider all theta values to be given in a number of radians. An Arctic village skiing trail has a radius of 1 kilometer. You see the radius of 1 kilometer here. A skier started at position 1, 0 on the coordinate axes and skied counterclockwise. Label the points 0, 1, negative 1, 0, 0, negative 1 on the coordinate axes in the diagram above. So I'm just going to consider to the right is a positive direction and up is also a positive direction. So if we went to the right 1 unit, then we're going to go to the left. This will be negative 1 and the y coordinate is 0. If we start at the center of our circle and go up 1 radius, then we're 1 kilometer away, but that's the y coordinate. And then 0, negative 1 will be right here. What is the angle measure in radians of the angles that have an initial ray passing through 0, 0 and 1, 0, and a second ray that passes through 0, 0 and the following points? So let's just draw our initial ray in red. Notice it goes through the point 0, 0 and 1, 0. And then our next ray, let's call this one green, goes through 0, 0 and 0, 1. So it goes this way. And so what is this angle here in radians? There are pi over 2 radians. Okay, so I just know that from prior knowledge, but let me think about a way to explain why that is so. Notice that the radius is 1. That means the circumference is 2 pi r, or 2 pi times 1, which is just 2 pi. And anytime we have a radian measure, we get to know how many radians we sweep out. Now, we know that all the way around there are 2 pi radiuses in the circle, and here we've only gone through a quarter of the circle, so we can take the entire circumference and divide it by 4 and we get pi over 2. That's how many radians. And it's a little more than 1. Like, you could put that in your calculator and see what the value is. So we go 1 radius and then a little bit more than 1 radius there. So then the one that goes through 0, negative 1, let's use blue for this one. So now our angle theta goes, here's our initial point, and then it goes this way. Guess I could call that angle alpha. And notice that of our circumference, we've taken half of it. 2 pi over 2 is just pi. This one is pi radians. The last one I'm going to use pink for the terminal side of our angle. So we start here and we go around counterclockwise. Skier skiing around this direction. This angle, I'm going to call it beta. Beta, it's the arc length cut out is 2 pi over 3. The entire circumference, but we've we're taking 3 pieces of it, which is just 2 pi over 3. That's good enough. 2 pi over 3 radians. Again, this goes back to the definition of radians. We cut out, that angle cuts out 2/3 of the circumference of the circle. And since the circumference is 2 pi, then it's 2 pi over 3 radians. Or really 2 pi over 3 radiuses go all the way around. Radii, I should say. Illustrate the radian measure in decimal form of each of the angles. So we can just type this in our calculator. So we get 1.571, 3.142. There's the familiar pi. Some of you guys might know that to several decimal places. And then 2 pi over 3 is 4.712 radians. If we went all the way around, we'd get 2 pi or 6.28. An Arctic village skiing trail has a radius of 1 kilometer. A skier started at the position 10 on the coordinate axes and skied counterclockwise. After skiing counterclockwise, the skier paused for a rest at the point 0.5, 0.87. So I'm going to find that on the graph up here. 0.5, that's about halfway here. Then 0.87, I think that's this point, perhaps. Pretty close to around that point. Describe what the value of 0.5 represents and illustrate this measurement on the axes above. Well, 0.5 is this purple distance here. So 0.5 kilometers. You could say something like the skier is 0.5 kilometers horizontally east from the center of the circle, something like that. And so if you wanted to describe what the value of 0.87 represents, you could say something similar. You could say that this value represents that the skier is 0.87 kilometers vertically north from the center of the circle formed by the trail. So if we go vertically north from the center, here's our 0.87 kilometers. So the center of the circle is our origin, and this coordinate tells us how far we are east of the center and how far we are north of the center. Recall that the sine and cosine function are defined as x equals cosine of theta and y equals sine of theta, given that xy is a point on the unit circle and theta is the arc distance from 10 to xy measured in radians. The unit circle with some points, labeled points, is shown below, in this case to the right. Use the unit circle above to generate a graph of y equals sine theta, where theta is the angle measure formed by the ray through 0, 0, and 1, 0, and a second ray whose origin is 0, 0 and sweeps counterclockwise around the circle. So let's make sense of this with this first point here. Essentially, we're looking at the angle that starts at this ray, that's the one through 0, 0 and 1, 0, and moves to this terminal ray. And this terminal ray is the one that goes through 0, 0, but through this point here. And so what is theta at that point? And it's saying that x is equal to cosine of theta, meaning this distance here from the center to the x coordinate, or the x value of this point, is cosine of theta. And this vertical distance is sine theta. Could have looked at the vertical distance here. And it also says theta is the angle measure formed by the ray through 0, 0 and 1, 0 and second ray. Okay. So how are we supposed to use this information to generate a graph? Well, all the y values are going to be our output, sine theta. So we have 0.71, 0.14, 0.61, 0, -1. We have lots of different outputs. And then our inputs, our theta values are going to be the inputs. The problem is we don't know what the inputs are. Here we can see that this looks like it's an eighth of a way around the entire circle. So we could say that theta is 2 pi over 8, which is pi over 4. So the angle corresponding to this pair would be pi over 4, which is about 0.785. Now, let's see, this point is at pi over 2. Which is about 1.578. 708. I'm going to start. I'm just going to make a little table here. In and outputs. So when the input is 0.78, 0.79 or so, the output sine of theta is the vertical distance here, the y value 0.71. When the input is 1.6, the output is 1. Let's see, we know that pi is right here. That's about 3.14. This looks like a little bit less than that, so maybe the angle is about 3 and the y value is 0.14. Just continue this table over here, break it into two parts. So when the angle is pi, or 3.14, we know sine of theta is 0. This point looks like 1, 2, 3, 4, 5, like 5/8 or something. So 2 pi times 5/8. It's about 3.9. Then the sine would be negative 0.61. This is 3/4, so 2 pi times 3 pi over 4, or sorry, 3 over 4. Gives us 4.7. So when the angle is 4.7, the output is -1. And then, let's see, a little bit more. Maybe we could just say that's about 5 or so. And then our output is negative 0.93. There's other ways to do this, I'm sure. That's just the one that first came to my mind. Now let's see if we can plot these values. So the input here will be theta. The output is sine of theta, those y values. Theta ranges from 0 to 5 or so, so let's just, we got quite a bit of room, so I'm gonna maybe go 1, 2, 3, 4, and then this is 1. Another 4, 1, 2, 3, 4, and this is 2, etc. So there's our inputs, and my output looks like it ranges from, let's see, we have some negative values, some positive values. 1 is the highest value and -1 is the lowest value. So let's see, maybe if we go up by tenths, so this could be 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9. No, that's not very good. We don't have enough room. How about by 2? So 0.2, 0.4, 0.6, 0.8. This would be 1. So we went up 1, 2, 3, 4, 5. Let's go down 5 to -1. Here's -1. I'm going to try to plot these values. The first one, when theta is 0.79, sine is 0.71. Notice that I went 5 tick marks here. So 1 divided by 5 is 0.2. Each of these are 0.2. So 0.2, 0.4. Nope, that's not right. There's only 4. Sorry. 1 divided by 4, 0.25. So each tick mark is 0.25. So 0.25, 0.50, 0.75. So 0.79 is just a little bit bigger than this. We're all the way at 0.71. And then we did go 5 up this way. So we need to go up 0.2, 0.4, 0.6. Let's see, 0.8 would be up here, 0.71, about right here. Yeah, somewhere around here. Then at 1.6 we're at 1. So 1.25, 1.50, 1.6 we're at 1. Then at 3 we're at 0.14, not very high. At 3.14 we're at 0, and at 3.9, almost to 4, we're at -0.61, -0.2, -0.4, -0.6. At 4.7, 4.25, 4.5, 4.75, we're at -1, and at 5, we're at -0.93. And think about what would be at 0. When theta would be 0, we wouldn't have gone through any angle. This vertical distance would be 0 also. So we have something like this. And that should be the familiar sine curve. It'll repeat as we go around the circle. It's a little bit too high. 1 is the amplitude. That's as high as we go. If we went negative, if we went, let's see, clockwise around the circle, we just go this way and have the same sort of pattern. What is the domain of the sine function? What is the range of the sine function? So my initial instinct is to say the domain is all real numbers, and I just already. The idea here is that we can pick any value of theta that we want to, We could keep going around the circle and make theta infinitely large, or we could go clockwise and have negative values of theta. What is the range of the sine function? Remember that the range is the set of all possible outputs. We never go higher than 1 or lower than -1, the value of our radius. So the range is the set of numbers from -1 to 1, inclusive. As theta varies from pi over 2 to pi, how does the output of the sine function vary? So pi over 2, that was 1.57. So this value here. And then it says that we're varying from pi over 2 to pi. Pi was the 3.14. This value here. So what happens as we go from theta being this point right here, and then going a little bit further right here? What happens to the vertical distance? We see the vertical distance decreases. We could also see that on the graph. 1.6 is about right here. Pi is right here. Notice the sine function decreases, and we're also concave down, it appears, which means that the rate is decreasing. We could also say that it decreases specifically from 1 to 0. That's not too important. It looks like we just answered question C. What is the concavity of the sine function on the interval pi over 2 to pi? Concave down. Use the unit circle above to generate a graph of y equals cosine theta. So this won't be too hard now that we've got all the angles. I'm going to create a similar graph. So I have everything labeled here. Now this really, let's see, let's go back up here. For the cosine theta we need the x values. Those are going to be our outputs. So when the input is 0.79, the output is 0.71. So it's the same point that we started with as with the sine function. 0.75 and 0.71. Somewhere around here. Next, when we're at 1.6, the x value is 0. .25, 1.5, so 1.6 here. We're at 0. So again, now the x values are the output and thetas are the input. Here at this one, we said that was about 3 radians, and the x output is really close to -1. And then when we get to 3.14 radians, or pi radians, our x value is -1. Let's see, now at 3.9 radians, the x value is -0.79. 3.9 -0.79. -0.25, -0.5, -0.75. see. No, these are 0.2, 0.4, 0.6, 0.7, maybe somewhere about here. And when the input is 4.7, the x value is 0. That's our cosine of 4.7. And then at 5 radians, 0.38. Now think about what the value would be when theta is 0. When theta is 0, like right, theta is 0 here, the length of the vertical distance would be 1, or the horizontal distance would be 1. So at 0, we're actually starting at 1. Then we have a nice cosine graph that looks something like this. And then that would just keep going. Periodic function, meaning it repeats, it has a period. And we could go the same direction the other way. Same sort of shape. As theta varies from 0 to pi over 2, how does y equal cosine of theta vary? So notice here as we go from 0 to pi over 2, we decrease at a decreasing rate, just like with the sine function from pi over 2 to pi. That tells us that we're concave down. An Arctic village maintains a circular cross-country ski trail that has a radius of 2.5 kilometers. A skier started skiing from the position 2.50 and skied counterclockwise for 2.75 kilometers before stopping for a rest. Explain what 2.75 over 2.5 represents in this problem. Let's see, 2.75 kilometers divided by 2.5 kilometers. That's interesting. That looks like an arc length divided by a radius. So that tells us, let's see, an arc length divided by a radius, that'll tell us an angle in radians. It tells us angle theta here. So basically, the angle that the skier has traveled through relative to the center of the circle. This value is 1.1 radians. Notice that 2.75 is a little bit more than 2.5. It's really 1/10 more. So essentially what we've done is we've skied 1.1 radians. That's the distance. If we want to measure our distance in radians, that's how much we've skied. Determine the ordered pair measured in radii on the coordinate axes that identifies the location where the skier rested. So this point right here. There's probably all sorts of different ways to solve this one, but we're looking for the point, the x and y coordinates, the ordered pair. So we need to find this distance x, which is cosine theta, and this distance y, which is sine theta. So you could For example, put cosine of 1.1 into your calculator. Make sure you're in radian mode. That is 0.454 about. And sine of 1.1 about 0.89. Now let's think about what that tells us. 2.5 kilometers is all the way across, so this is saying that this is equal to 0.454, but that doesn't make sense because it looks like about halfway, meaning it would need to be about 1.25 kilometers. So what's going on here? Notice that 0.454 is about halfway. It's close to 50%. If we multiply that by 2.5 kilometers, (1.135 kilometers), that's actually what this distance is here. This cosine of theta, remember that that's defined on the unit circle. So what it tells you here is that we have 45% of the radius is that distance, 1.135 kilometers. And here sine of theta, that's 0.89. It's 89% of the radius. So 89% of 2.5 kilometers is 2.225 kilometers. That's this vertical distance here. So let's look back at the question and see what we're even asked. Determine the ordered pair measured in radii on the coordinate axes that identifies the location where the skier rested. So notice it says measured in radii. We are 0.454 radii away, so our point is cosine of theta sine theta, or cosine of 2.75 over 5 sine of 2.75 over 5, or 1.1, which is equal to about 0.45, 0.89. Those are in radii. That tells us that we have 45% of the radius horizontally and 89% of the radius vertically, which we found was 1.1 kilometers horizontally and 2.2 kilometers vertically. Oh, and that was the answer to the next question. The skier then continued along the trail, traveling counterclockwise until he had traveled for a total of 10 kilometers before stopping for another rest. Okay, so now we go 10 kilometers. So that's our arc length. And the radius is still 2.5 kilometers. That means that our angle theta is 10 over 2.5, which is 4 radians. that means that the ordered pair of the position is cosine of theta sine theta, or cosine of 4 sine of 4, which is negative 0.65, negative 0.76. So if we go 10 kilometers around, so 2.75, 5 somewhere around here. Let's see, we're 65% away this way, 75% this way. So let's see, probably somewhere about right here. And so then, if we want the ordered pair in kilometers, we just multiply each of those values by the radius, so 2.5 cosine theta, 2.5 sine theta. That will give us our value in kilometers. 2.5 cosine of 4 is about negative 1.63, and 2.5 sine of 4 is about negative 1.89, and each of those are in kilometers. So this point up here is 1.63 kilometers, let's see, horizontally from this vertical diameter, and then it is about 1.892 kilometers vertically down from the horizontal diameter. Consider a coordinate system where the coordinate values of a point are measured as a number of radii. What is the general form of an ordered pair expressed in a number of radii of any point on a circle that has a radius length of r kilometers and an angle measure of theta radians? So we want this angle right here. The answer is cosine of theta sine of theta. And I think I could spend about all night thinking about this one. So I'm just going to go ahead and imagine that the unit circle is inside of this larger circle. So here we have the unit circle. This is the point 1, 0, 0, 1, negative 1, 0, 0, negative 1. Because remember that cosine of theta and sine of theta are really determined for the unit circle. So this point right here is cosine of theta sine of theta. Now since the radius is 1, it tells us, okay, we've gone cosine theta across. But then notice the distance here across, the horizontal distance is longer to get from here to here. It's longer than cosine theta. Now, in terms of radians, it's the same length. It's the same number of radians. If you look at this proportion of the circle here, or if this horizontal section, and compare it to this one, they're proportionally the same. So essentially what cosine of theta and sine of theta tell you are how many radius lengths. Let me put this a different way. You may remember this SOHCAHTOA idea from high school. If you have a right triangle and an angle theta, sine of theta is the opposite over the hypotenuse, or in this case it's the y-coordinate, the vertical distance, divided by the radius. Notice that we're taking, we have a fraction here. This is actually the percentage of the radius that y takes up. And cosine of theta is the adjacent over the hypotenuse, or the horizontal distance over the radius. Now when the radius is 1, sine of theta is just y and cosine of theta is just x. But if it's not, then y is equal to r times sine of theta, and x is equal to r times cosine of theta. Now if we wanted the actual distance in the units of the radius, we would need to multiply sine of theta and cosine of theta by r, but if we just want in terms of radians, we'll go ahead and divide each of these by r like we've done here, and this tells us how many radiuses there are in y, and this one, cosine, tells us how many radiuses there are in x. Anyways, if you forgot what the answer to this problem was, this is it. Construct angles on the unit circle with these radian measures: pi over 6, 5 pi over 6, 7 pi over 6, 11 pi over 6. First, recall that going from here to here, halfway around is pi radians. You could also remember that all the way around is 2 pi, so halfway would be pi radians. So pi radians is from here to here. So if we take this and divide it into sixth, we'll get pi over 6. So I first want to divide pi up into thirds as best as I can. So this is about pi over 3 from here to here. So I'll just call this pi over 3, just label that here. Then there's 2 pi over 3. And then all the way across, this is 3 pi over 3. But we really didn't want to label thirds. We wanted to label 6. Well, a half of a third is a 6, so let's break all these thirds into halves. And so now, from here to here, this angle is pi over 6. Then if we go here to here, this one is 2 pi over 6, the same as pi over 3. If we go from here to here, that is 3 pi over 6, or the same as pi over 2. Then from here to here, there are 4 pi over 6 radians there. And that can simplify as 2 pi over 3. Then from here to here will be 5 pi over 6. This will be 6 pi over 6. Then we can keep going to get the rest of them divided again into thirds and then into sixths, so that we'd have 7 pi over 6. That's this angle all the way around. And then 8 pi over 6, which is the same as 4 pi over 3. 9 pi over 6, which is the same as 3 pi over 2. This one would be 10 pi over 6, the same as 5 pi over 3. And then from here all the way around to here, that one is 11 pi over 6, and we've got all of our angles that we needed to label. Pi over 6, pi over 6, 7 pi over 6, 11 pi over 6. So using your calculator, determine the coordinates corresponding to the angle with a measure of pi over 6 radians. So we can find, since this is a unit circle, just use cosine of pi over 6. Okay, so what that is the first coordinate here, square root of 3 over 2, which is about 0.866, and then sine of pi over 6 is 1/2, 0.5. So that just means that we go 0.866 percentage of the radius this way, and then 0.5 or 1/2 of the radius vertically. Let's see, for this one, 5 pi over 6, you can just look and tell that the coordinates are pretty much the same, except this one will be a negative square root of 3 over 2, and this one will be a positive 1/2, and you could confirm that cosine of 5 pi over 6 and sine of 5 pi over 6. And down here, it's kind of similar. We again have negative square root of 3 over 2 for our horizontal length, cosine of theta, and then this vertical length is now negative 1/2. And for this one, 11 pi over 6, we have positive square root of 3 over 2 and negative 1/2. So you can see that each of these pi over 6 radian measures have the same coordinates, but they're just the positives and negatives get switched around.